Okay, so I don't know what happened in the previous video. What happened was I think it just stopped recording. So where are we now? Alright, so we got to 11.6. I don't think this part came out. You can just pause the video at this point. Otherwise, we went on to number 9. We said that we're considering the 58,000 rand to the end. So it's going to be 58,000 into 1 plus 0.09 over 4. So it is compounded quarterly. And it's going to be 4 times the time of years, which is 2.25 of a year. Then we're going to consider 180,000 rand to the end. So it's 180 into 1 plus 0.9 over 4. Since it's compounded quarterly to the 4 times 1.5 years. From T9 over 12 to T2.25, it is 1.5 years. And then 120,000 to the end. That's going to be for 2 years. No, for 1 year, sorry. And then your 220,000 rand to the end is going to be for a quarter of a year. Okay. So what I did was I'm going to put in the calculator 1 plus 0.09 over 4. Let's say that is an answer. Okay, so whenever I see this here, I'll put the answer, press the answer button. The calculator, okay? So we're going to get 580,000 answer to the exponent 4 times 2.25. So it's 2.25 minus 180,000 rand answer to the exponent 4 times 1.1 minus 120,000 answer to the exponent 4 minus 220,000 answer to the exponent 4 times 0.25. Okay, just put it 1. So it gives me an answer of 164,000. Is that correct? 146,000. 766,03. Okay. Any confusion? Any confusion, people? All right. So now we're looking at nominal and effective interest rates. Nominal and effective interest rates. We're on page 385. So we're told that nominal and effective interest rates. A nominal interest rate is one where the interest rate quoted and the compounding periods are different. Example of nominal interest rates are compounded quarterly, 12% or 9% compounded monthly. So that means to say that if you're talking about compounded monthly, compounded weekly, compounded daily, compounded quarterly. All of those different compoundings is considered as your nominal interest rate. You guys understand? And then if that is your nominal, your effective interest rate is going to be when it says compounded yearly. Does it make sense, people? Alright. Then we are told that it's common practice to quote interest rate per annum, but the compounding period can be quarterly, monthly, daily. These interest rates are called nominal, as I just said now. An effective interest rate is where the interest rate quoted and the compounding period is the same. So here the examples are given as 12% per annum compounded annually, or 11% per annum compounded monthly, or 12% per quarter compounded quarterly. But to us, an effective interest rate is something that is compounded yearly. You see that if it says 1% per annum compounded monthly, then the yearly interest rate on that is straight as 12% compounded annually. Does it make sense? You see, if the compounding and the interest rate is the same, so if it's per annum is what? Per year. Compounded annually. So how many times does interest get added to the account? Per year. Once a year. You understand? So if the compounding is the same as the interest rate, then it's considered as a effective interest rate. Okay. Now if you look at an interest rate 12% per annum compounded monthly. Per annum means what? Years. Compounded monthly, how many parts in a year? 12. So is that the same? How can it be the same? 12% per annum. So your rate is 12% per annum compounded monthly. Is this is per annum, so that's per year. How many parts, how many times a year is going to compound? 12 times interest will be added to the principal for that year. So is this the same? No. So what type of interest rate is this? This will be considered as either nominal or effective. Which one of the two? Nominal. If it's 8% per annum, compounded quarterly. Nominal or effective? Nominal. Because this is 4 times in the year, and that's your rate per year. You understand? So if it's 11% per annum, compounded yearly, is that the same? Yes. So this is effective. Make sense? Shh. You are somebody who said yes now. Okay. Otherwise, we're never going to get through this. Right. So, okay, this is going to even make you more confused. Okay. So, let's look at a calculation, how this actually gets calculated. If you got, say for argument's sake, me just explain where this is going to come from now. If you get the following, you got 5,000 Rand, that's invested at 10% per annum, compounded yearly, annual, monthly. I would like to know what would the compounded yearly equivalent be. So you all agree this is a nominal interest rate. Right. So the question is determine the effective interest rate. Hopefully this will explain to you your misunderstanding. Okay. So we have, if you want to calculate this part of the sum, you want to calculate your return. Then you're going to say A, how do you calculate your return here? A is equal to P into 1 plus I to the exponent Okay? So, my formula here, for this case here, would be A is equal to P, which is 5,000, into 1 plus 0,1 over 12 to the exponent, 12 times 1. Save says for 1. Okay? You all agree with that? So that will go whatever the return is. Then I would want to calculate the effective interest rate that will give you the same return. Okay? Which means to say the A value is going to remain the same. Your P value is going to remain the same. And your time in years is going to remain the same. That 1 remains 1, not so. So if I go with that formula, we say, okay, that is equal to, since this is your A, it's equal to P, which is 5,000, into 1 plus, remember, this is an effective interest rate, or a yearly interest rate, or a compounded annually. So that will be I to the exponent n, which is 1. You all agree with that? Then what happens here is that if I want to calculate I, this will be dropped here, the 5,000s cancels. Not so? So in other words, to have calculated 10% per annum compounded monthly to an effective interest rate, I didn't actually need it to have done this. Because what if it was 100,000? We'd have cancelled. If it was 5 million, we'd have still cancelled at this point. You all agree with that? Let's say this could have been any amount here. It could have been a compounded quarterly. It could have been a compounded daily. It could have compounded weekly. So the compounding there could have been anything. Let's call it an M for now. So if that is an M, that would have been an M as well. Not so? So in other words, what we must consider is that for the same return, the formula would be P into 1 plus I, the interest on its compounding as stipulated, over M, which is the amount of compoundings there are, to the exponent M. Remember, that value and that value will be the same. I could have cancelled that also at that point. What if it was for 2 years? That would have been 2 and 2. Can you see that? If it was for 8 years, that would have been 8 and 8. So if I take the 8th root both sides, cancels each other. If it was for 2 years, square root both sides, cancel each other. So that doesn't have any bearing on my calculation then. So what I'm doing is, I'm rewriting this in general terms. So that would be simply 1 plus I. Okay? Remember, that would be your P on the outside as well, but at this point we're going to drop the P. Our formula now will be simplified into 1 plus I to the M, which is your compounding, over M to the exponent M is equal to 1 plus I effective. Let's call that effective. Okay? You guys confused? Yes. Okay. Let's go again. Yes?
What I still don't understand is what is that M for next to the I?
What that M is for. You see this I and that I both is I's, no? Did you see both is I's? Both is interest. However, we can't have both I's there. Because if you say that is an I and that is an I, then that means to say the I's has to be the same thing, the same value. Like if you got an equation, say you got an equation 1 plus x plus 5x equals x. Then what do we know? That this value of x there, the same value as x there, and is the same value as x there. Not so? You all agree with that? So if I say this is x1, That's x2 and that's x3. Are those x's the same? No. Likewise, when we say this is I to the m, that m has no bearing on that I. It is just an I value. However, that I is never equal to that I, or is not the same value. Okay? That's why we say I to the exponent m and I effective. So that you know this is a nominal compounding and this is your effective, your interest rate. Okay? Let's look at the example. Just remember this formula here is your conversion from nominal to effective. You can write it down. It's going to be 1 plus I effective equals 1 plus I to the exponent m over m to the exponent m. This formula is not given in the exam, so you must memorize this formula. Okay? So let's look at an example. Okay. Yeah, you can read through page. For those of you who really want to know where this formula come from and still don't understand, you can read through page 386 on top there. They explain to you where that formula comes from. Okay. We have like a few minutes left before the bell rings. I just need to do a couple of examples on this. Okay. Yes.
I'm sorry, what is the formula for, sir?
Changing your nominal interest rate to a effective interest rate. And all this is compound interest, no? It's not simple, it's compound interest. Okay, so this example 1 on page 386. So we are told that convert a nominal interest rate of 13% per annum compounded monthly to an effective interest rate compounded annually. Okay? So what's the formula? So when you do these calculations, you write this formula down all the time. So that after a couple of calculations, you have memorized the formula. So what's the formula? 1 plus I effective equals 1 plus I to the exponent m over m to the. So if you look at this 13% per annum, is it I effective or I to the m? Which one is going to be? The question says convert a nominal interest rate. So it has to be nominal. Not so. But if they didn't say it's nominal, it says calculate the interest rate of 30% per annum compounded monthly, then you should have known it's this one here on that side of the equal sign. Not so. The question says to an effective interest rate. Effective interest rate is a yearly interest rate. So in other words, you're calculating this year. Not so? Right. So, let's go. It will be 1 plus. What is I in this case? What's your I value? 0.13 over 12. Why 12? It's monthly. To the exponent? 12. Okay, so that will be 1 plus I effective. Okay. Okay. So now what we do is we punch this in a calculator and we subtract 1 from it. That's going to be open brackets. 1 plus 0,13 over 12. The exponent 12. Okay? Then what do? Minus 1. That's 0,14. Also? But that is for I effective. But they want your effective rate. You see, they ask for rate and not your I value. So what must we do with that answer? Multiply it by 100. It gives you 13,8%. So that is to say, if you have invested, say, 100,000 rand, no? For 5 years, say you had 100,000 rand, and you invested for 5 years at an effective interest rate. It will give you the same return as 100,000 rand invested for how many years? This 8 years, for 5 years. 5. For 5 years. At a nominal interest rate of 13% per annum, compounded monthly. Will give you exactly the same return. I'll prove it to you now, okay? Let's go with the nominal interest rate first, because I have this answer on the calculator, okay? So let's see what we get. We say 100,000 rand into 1 plus the interest rate over 100. Okay, that's the last calculation, calculated here, over 100. To the exponent, what? How many years is that for? For 5 years. So that gives me a return of 190,000. 190,885,65. So let's see how much will this give us a return of. So it will also be 100,000 into 1 plus what? 0,13 over 12 compounded monthly to the exponent 12 times. How many years? 5 years. You see exactly the same answer. Okay? That's going to give us 190,885 rand and 65 cents. It's down to this exact same. Of course, if you had rounded this off and have used 13,8 instead of that answer button, then of course the answer would be very close, because that's a rounded off value. But since I use the answer button, it's the exact value on the calculator. So just to bring it back to layman's terms, okay? What the answer that we have calculated here, the effective interest rate that we have calculated here, is the equivalent of that interest rate converted to a year's value. So what we do is, by doing this conversion, it will give us the same return in both calculations. If that makes any sense to you. Okay. You understand now? Okay. Let's do another example. Okay, yes, what's the question? Somebody have a question? No, okay. Which page is this on? Sorry? 386. Example 2 on page 386. They want to know which of the following interest rate would be the best investment over a period of 5 years. The best investment over a period of 5 years. So, what we need to do is, when we convert, if we compare two fractions, okay, we know this one is bigger. But let's say we didn't know. We act stupid. We say, okay, we did it. Then what do we do? What did we need to do in order to see which one is bigger? You know, it's the same. So we needed to have a common denominator to, okay, not 2, it's 15. So it's 15, so it's going to be 6 and 3 is 12, no? So that's of course bigger. Not so? Am I right? Yes. So in this case here we've got the compounded annually, we've got the compounded quarterly, compounded day. So what are we going to make the same here? We'll have to then convert everything to an effective compound. Not so? So there we already have compounded annually is an effective interest rate. Not so? If it says compounded annually, it's effective interest. You understand? For B, let's look at B. You got 1 plus I effective equals 1 plus I to the m over m to the exponent m. Alright? So it's 1 plus I effective equals 1 plus 0,139 compounded quarterlies is over 4 to the 4. So your I effective for B would be, open brackets, 1 plus 0,139 over 4 to the exponent 4 minus 1 times 100. So that gives you 14,64. Okay, let's look at B. Sorry, that was B. Let's look at C. You got 1 plus I effective again equals 1 plus I to the m over m to the m. So it's 1 plus IE equals 1 plus 0,137 over dailies 365 to the 365. So I effective here will be 1 plus 0,137 over 365 to the 365. Gives you minus 1 times 100. So that gives us a return of, not a return but an interest rate compounded per annum at that rate. So between these three already, what can we see? Which of the following interest would be the best investment? So the best investment has the highest interest rate, not so? If it was a loan, it would have been the lowest interest rate would be a better thing. You guys understand? So at this point already, yeah, we got this one. B is 14.64. So B is better than A. Here we got 14,68. So C is better than B. Not so. So this is the last calculation. So at this point, C is the best. Let's look at D. Is 1 plus I effective equals 1 plus I to the m, which is 0,1385, sorry, over monthly, so it's over 12 to the exponent 12. So your rate, effective rate, is not that you are, would be, open brackets, 1 plus 0,139585 over 12 to the exponent 12 minus 1 times 100. It's 14.76%. So as you can see, all of this is compounded yearly. So it's a fair measure now to measure up against each other. Not so? So therefore, D is the best one. Not so? So the question says, which one is the best over a 5-year period? So the answer is therefore 13.85% per annum compounded monthly would be the best investment over 5 years, because the interest rate in comparison is the highest. Okay, you guys understand? Okay, it's easy now when I'm bowing to say, okay, I understand. Right. People, example 3 is something we will be. Ever seen? We'll go now. Don't worry. No? Example 3 we'll look at tomorrow. So we're going to work to one direction only. We're only going to work as in the examples that we did today was calculating the effective interest rate. Okay. So for homework, I want you guys to do exercise 11.8, and this is on page 388. You do for me number 1. Number 3. Number 4 is the same as we just did now on the board. Okay? Number 5 is also the same. So you do number 5 as well. Number 9. And you do number 9 as well. People, enjoy the rest of your day. Good morning, good afternoon, class.